Hi, everybody, and welcome to today's Seed World Canada Retail Strategy webinar. My name is Mark Zinkowitz, and I serve as editor for Seed World Canada. And today I'm happy to be your host. Our theme today is leveraging artificial intelligence for accurate seed identity verification. We're going to hear from several experts who will talk about the intricacies around this technology, its uses now, and possible uses in the future. Before we begin, I would just like to thank our sponsor, CCAN, for their support. As well, this webinar is being recorded and will be made available in the coming hours on our website, seedworld.com/Canada. Also, if you have a question, simply type it into the chat box at any time. You don't have to wait until the end of the webinar. You can type your question in any time, and we will address it at the end of the webinar when we do a brief Q&A. Please just let us know who your question is directed to, if it's directed to a specific person. Now, like I say, with advancements in artificial intelligence really transforming the landscape of seed variety identification, there's a lot of new opportunities to enhance product quality, boost customer trust, and really streamline logistics. Now, this session is going to explore how AI technology is really setting new standards for accuracy and efficiency. It's helping to verify seed variety identity and meet really rising industry expectations. So, we're going to number one, understand how AI is being used in seed variety identification. Pardon me. We'll hear a couple of case studies with the Canadian Malting Barley Technical Center, the CMBTC, and a company called Zoom Agri based in Argentina, who are going to talk about some real world applications of AI in action. We're going to talk a little bit about enhanced trust and brand integrity, about how accurate AI-driven variety identification can really improve customer trust and enhance the seed industry's reputation. And we'll talk a bit about improved supply chain efficiency as well. Now, we have actually 5 speakers today. You'll see 4 up on the screen. Just going to introduce everybody here. We have Peter Watts of the Canadian Malting Barley Technical Center. Hello, Peter. We have Augustine Uranga from Zoom Agri. We have Olha Zaharuko of the Canadian Malting Barley Technical Center. Todd Hyra is Western Business Manager for CCAN. And not pictured here is Mitchell Japp of Sask Barley, who is going to talk with us as well. Now, Todd and Mitchell couldn't be on live today. I think Todd is probably in an airplane right now, and Mitchell had some last minute travel changes as well. So I pre-recorded my talks with them on Monday. And so we're going to start off with Todd now, who is going to introduce us to this technology and how he first happened upon it. So let's play that very short talk from Todd. It's about 3 minutes long, and then we will have a talk with Augustine. Thank you, Todd, for joining us on the webinar. How are you today?
Doing great. Thanks, Mark.
Thank you for your time. Now, we're going to be talking about this variety identification technology and some of the potential applications of it. But before we get to that, I want to kind of rewind and set the stage for people. And you told me an interesting story about being introduced to this technology from Zoom Agri. I was hoping you could tell that for the audience. The first time you saw it, what the circumstances were, and just what your reaction was to it.
Well, there's a couple of different levels. So first of all, when I first heard about the concept of using digital imagery and AI to do varietal ID, I thought, well, that's pretty far-fetched. I can't see this working. So that would have been in the spring of 2023. And then over the course of the spring, we supplied samples so that the algorithms could be built by Zoom Agri and start to pull the system together. And so I happen to have my marketing rep team in September of last year, September 2023. And so we collected a handful of different samples. And one of the ones I grabbed was a sample that I had used to take to class and show school kids what barley looked like. And so it had been kicking around my garage for 10 years. It was just barley. I didn't know what it was. And so we took our known samples and we took this unidentified sample in and tested the system out. It was really mind blowing to see how fast it was, the speed and efficiency of the system compared to DNA testing was remarkable. And so turns out the sample I had in my garage for 10 years was AC Metcalf, which was about right for that time frame. So to be able to have something that can generate results in literally 2 or 3 minutes to 97, 98% accuracy is amazing.
Yeah, that's pretty incredible. And as far as CCAN is concerned, in terms of, potential applications for this that you see down the road, what comes to mind for how this, might be of use to the industry, to CCAN's customers, things like that?
Yeah, so from a seed perspective, I see it as being that one extra step that a seed grower can use to make sure that there was no big mistakes. Like 97, 98% accurate, that's pretty good, but that's not as accurate as what a seed grower needs to be. They need to be 99.99% of what they're doing in their field. But what it does is allow them to test in an affordable way to make sure that something didn't get dumped on top of one another or there was a mistake in a process. And so I see it as a great supplemental piece to what seed growers are doing now and helping provide just an additional level of customer assurance.
Yeah, I think so. And then we're going to hear from Zoom Agri as well as Mitchell Japp from Sask Barley and Peter and Olhoff from CMBTC as well for how this is being used in some of the future applications. So thank you, Todd. Looking forward to seeing what comes down the pipe in this regard. And have a good day. Thank you so much.
Thank you so much, Mark. It's a pretty exciting time, and it's really cool to see how AI can be implemented to add efficiency and cost savings to normal things in agriculture.
Yeah, there's a lot more to AI than just Chat GPT, right? So it's pretty exciting. Thanks,
Thanks,
Todd.
Mark. Take care.
Thank you so much to Todd for that. Welcome, Augustine. How are you?
Hi, Mark. Very good, and you?
Good to see you. Now hold on, I'm just going to
Good to see
load
you.
up your slideshow.
Good to see you too. I'm very, very happy and proud to hear Todd. I mean, we met like a year and a half ago, and listening him, it's like fuel for us to keep on trying to bring solutions to the industry, right?
Yeah, well, exactly. And no, thank you for your time today. Now you're based in Argentina, but you're actually in Minneapolis at the moment, so you're a little bit closer to Canada. Now I'm
Yeah.
curious, Augustine, Zoom Agri. How was Zoom Agri founded and why? Can you give us a brief synopsis or to tell us that story?
Oh, sure. It's a pretty funny story, and I think uh, that's one of the key things on why we are doing so well, right? Or I think we are doing well, right? Uh, how Zumagri was created. So we have three co-founders, uh, Fernando, Yap, and Matias. Matias previously, before founding Zumagri, he had a wind energy system that he was trying to sell, but with solar panels, like solar panels kill the wind energy generators. So he had to get out from that startup, but he loved the agri industry, right? So he stayed 1 year studying the whole industry, trying to find ideas for potential solutions that could bring to the agri industry, and that's how he met Yap and Fernando. Yap and Fernando, they were traders for 13 to 15 years, and they have been working in the agri world. So they had someone in common. They introduced them, and one of the ideas was to be able to do the grading using pictures and AI. So at that moment, or today still like that, grading is being done by human eye. So enabling the industry to do it with images using AI at a faster way, at less cost and more precise, it was a huge idea. So that's how they met and how they started the company. And why did we start it with variety at the end? That was not the first idea. That's because we had a very interesting meeting in 2017 with AB InBev. They were struggling with some problems with varietal purity, so they asked us to see if we could do that. And today, well, we're on the mission of transforming this whole industry that is testing, inspection, and certification of agri commodities, starting by, as I mentioned before, digitalizing the quality determination or grading and variety recognition.
Yeah, it's pretty amazing. It sounds like science fiction, but really this is becoming more common. I know my wife is a real green thumb. She loves gardening, she loves wild plants and things, and like she has an app on her phone and there's many of these apps out now where you can take a picture of a plant that you see outside and then you upload it to the app and it searches its database using AI and it will tell you what species of wild plant that is. And it's really quite amazing. And so I just wanted to note that, yeah, these sorts of technologies, they might sound like, oh, wow, that's incredible. But really this AI driven ability to recognize things visually is just becoming more and more common now.
Yeah, and I think that the great challenge is to find practical solutions that solve a real problem in the industry or any industry, and how we can apply technology to real problem day to day situations that people are suffering, right? And I think
Yeah.
we are doing very well that.
Yeah. Well, and your machines are like they're available now in more than 20 countries. So I'm curious, what's been the international response to this? Are there unique ways it's being used in different regions? I'm with Seed World Canada, of course. So what we're really interested in today is how this is being used in Canada, especially in barley. But can you give us an idea of what's been sort of the global response to this?
Yeah, I'm impressed with the global response. I think in less than 7 years since the company was funded, we are working in more than 20 countries. I think before I joined the company, or even the founders before funding the company, they they didn't think that they were going to be in 20 countries so fast. But since the technology is adding so much value to the industry, the internationalization was faster than expected, I think, and it wasn't easy. I mean, in a lot of countries, we found people that were skeptic of when, hey, we can do this. Oh, I don't believe you. And at the end of the day, what we are always trying to do is to let the data speak, show results fast, and convince that people with results. I mean, we don't want to convince anyone just speaking, but with uh, results, data. Let the people test it, show them, compare them, and that's how, at the end, we are being able to uh, bring solutions to newer countries, right? And all that, doing it with image processing and AI. With all countries that we're working in, is using these three technologies: that is computer vision or image processing, AI, and the Internet of Things, right?
Now, seed identification. I'm curious how this technology is playing a role in this. I mean, you've trained your algorithm to really achieve high accuracy across different crop types and
Yeah.
varieties. Like, can you talk a little bit about that? I mean, how do you take, have an image of this seed and you put it into this machine and it's going to tell me what variety, like for example, of barley. It's going to tell me what variety of barley that is. It's like, well, to the human eye, well, barley is barley. It all kind of looks the same. But what you're telling me is this technology is going to tell me that specific variety is, Todd was talking earlier about he had a specific variety. I think it was AC Metcalf. He mentioned that's AC Metcalf or that's Copeland or that's this or that's that. I mean, that's pretty amazing.
Yeah. And or I think the why we are here today is mostly because of course the visions that the founders had when they founded, but we 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 are very thankful with our strategic partners, with our customers, and of course with our team. I mean, uh, some of the ideas that we today have a product working in a lot of countries came from from customers or strategic partners. So we would not be able to make it in Canada possible so fast if we were not working with the CMBTC probably, and also indirectly with SICAN, for example, because through CMBTC we were also working very close with Todd and SICAN. So the main challenges here are to try to collect pure samples because of how the technology works. At the end, you have to collect pure samples of the varieties that you want to be able to recognize. Then we digitize them. We store them in our database. Today we have a database with more than 500 million images, so that's one of our biggest assets. And then our team, as I was mentioning before, we are working like very how do I say it, like a very complementary team. Also, like the same that we have with funders, people from the industry and techies, we have at a level, like at the product level, we have very experienced people in AI, agronomists, and people with a lot of experience in the agri industry. And combining those three skills, I think it may enable us to bring real solutions. I'm obsessed with real solutions to day-to-day problems in the industry. And today, as you mentioned, as you can see there in the screen, we have like variety recognition and grading. And so far, we developed it for barley, wheat, and soybeans today. So regarding the variety recognition today, we discover that using a picture and AI, we can identify at a 97, 98 precision barley varieties, wheat varieties, soybeans varieties. So that's crazy, because previously, before our solution, traditional methods like DNA or electrophoresis, it took probably a week or 2 weeks to have the result, and it cost like $40 to $200. So today is it's crazy to think that you can have just in 2 minutes and at a fraction of a cost with a 97 98% of accuracy that result. It's changing the whole like seed industry, and in some cases the whole industry, right? So that's
Yeah,
amazing.
yeah, it is, and it's I'm interested in, and Mitchell's going to talk a bit about that right away. Is how genetic testing is as important as it is. We need genetic testing, but like it can take days to get
Yeah,
results back, and so this is something that when appropriate can be used to quickly identify a variety, and there's so many implications of that, specifically with regards to sustainability,
yeah,
right?
and
Like this is something we talk about so much now, sustainability, and so this just really helps improve resource efficiency, and I guess it can contribute to even more sustainable farming practices at the end of the day. No.
yes, 100%. And going a little bit back to DNA, that I'm not an expert. I mean, it's still the most precise method. They are completely precise, like
Yeah.
sorry, completely complementary, like one help the other one. Okay, so and even DNA is helping us to build our algorithms because we're constantly validating, and so we're always saying that they're complementary methods. And regarding the sustainability, uh, yes, we are like sure that we are collaborating to the future of the agri industry to make it more sustainable. And as you said, I mean, one of the main challenges in the future is going to be how to feed a lot of more people with the same hectares seeded, and how producing more. So uh, farmers need to be able to access to that varieties with technology and with the better genetics to have a better yield, for example. But behind that, we need the breeding companies and seed companies to keep on being able to invest in the best practices possible, breeding possible, technology possible, and so they have to make their business sustainable, and enabling them to be able to detect variety, to sell better seed, receive make sure that they receive better seed, and to control the system, or uh, to make sure that they are being able to pay back their investments. It makes the seed industry more sustainable or sustainable, and will help the whole world to have more food at the end of the day. And in terms of efficiency, the use of resources, like for example, there are some of our customers that are malting companies. Um, they told us that they are saving like a lot of water and energy because they are being able to guarantee that purity. So that makes that the process of germination more homogeneous. So they are not wasting too much water and energy as they were doing before. And of course, being able to have a more transparent agri industry, it will prevent in the future thousands of trucks moving from one place to another unnecessarily. Okay,
Mhm.
so I think mostly in those two topics we are collaborating a lot. And as as you can see in our screen, I wanted to to give you some of our milestones that we achieved in these years, just in 7 years. We achieved last year our 1 million analysis performed in all our customers. That was something that we are very proud of it. We have more than 5 devices installed worldwide. As I mentioned, we have more than 500 images, 500 million images in the database, working in more than 20 countries and with more than 100 customers. And we let the data speak by ourselves, right? It's not a story, it's just working hard and bringing solutions to real day problems. And I think we started with this, but those are Fernando Yap and Matias faces from the story that I was telling. Today we are more than 80 people with a very complementary teams that I told you, like I told you, and we have locations in Argentina, Spain, sorry, two in Australia and Brazil, and hopefully soon our next location or office probably is going to be in North America. So very excited to keep on bringing solutions into Canada.
Yeah.
Yeah.
Yeah, no, that's pretty amazing. And it's a really great story to tell. And that's what we're going to hear from Mitchell next, talking a little bit about some of the implications of this on the barley side. And then we'll talk with Peter and Olha about how this is being used specifically in barley, especially malting barley, and how it works. So thank you, Augustine, for
No,
your
thank you.
talk. Hang on the line. We're going to do
Yeah.
a Q&A shortly, but we're going to hear from Mitchell Japp now of Sask Barley, who's going to talk a little bit about some of the practical implications of this. My talk with Mitchell was about 4 minutes. So sit back, we'll hear from Mitchell, and then we'll talk with Peter and Olha and do a little Q&A. Thank you, Mitchell, for your time today, joining us on the webinar. How are you?
Pretty good. Thanks, Mark. I appreciate you inviting me on here.
Yeah, well, thanks for your time. And we're talking about this variety identification technology and how it could be implemented in the barley industry and potentially beyond that. And I know having talked to you before, I've done interviews with you and we've talked about these issues. And, genetic testing for crops, barley in particular, can take a while right now. It can take days to do that. And I'm just curious, this sort of variety identification technology that we're talking about today, what kind of impact do you think it could have on the barley industry and on barley producers in general?
Well, I think the real attraction of this type of technology is to be able um, to have something that's really rapid and relatively low cost. It's not even relatively low cost; it's just super low cost. It doesn't cost much to run a sample through through the systems, and I think for the potential of what that could mean is something like this could be in the elevator. So when the sample gets pulled from the truck in the line, it could be tested and have results by the time the truck's in the elevator to unload the grain. When a producer delivers the grain, the sample gets taken, uh, gets shipped away and tested. But by that time, the grain's already gone. And so if they happen to fail that purity test, then it reduces their marketing options as what they could have had beforehand. And so, including an AI technology where perhaps that could be sent away for low-cost testing before grain's ever delivered, or even better, in the line at the elevators, so that if it fails that test, the producer can not unload the grain and drive away and make a different assessment of how they might choose to market that grain. That's really it would be really a useful option for producers to be able to have.
And do you have any thoughts on how reliable this technology needs to be, like for it to become mainstream and be used for this? Like, is there some sort of testing that would need to be needed before it's adopted? Anything like that?
Yeah, absolutely. And I think that's the initial steps of what the project that SaskBarley funded with CMBTC was to look at this technology, was to test whether it can be validated and to start looking at how robust it could be. I think what you're looking for is consistent results with the same samples. You run it through multiple times. It's a nice, this non-destructive test, so you could run everything multiple times and be able to get hopefully the same results. So that would have to be compared against industry standards. So like the genetic testing that we have, you can test it with high generation of pedigreed seed where the level of purity is going to be very high. And then you can potentially even create mixtures of known impurities and be able to test the machine's robustness against that, which is what should be happening with genetic testing as well. It's those are kinds of things that we need to have to know that the systems are robust and able to detect impurities properly and accurately.
Yeah, sounds like something where there's lots of potential for the future, and looking forward to seeing what comes down the pipe. Thanks for your time today, Mitchell.
Absolutely, very much appreciate it, Mark.
Thank you so much to Mitchell for that. Now I'm going to welcome Peter Watts and Oha Zaruko from Canadian Malting Barley Technical Center in Winnipeg. Thank you for joining me. How are you today?
Good, thanks, Mark. Nice to be here. Thanks for inviting us.
No, not a problem, Peter. Thank you, Oha. How are you?
Fine, thank you.
Great, great. Now, you are using this technology, as Mitchell was saying. You've been doing this trial with help from organizations like SaskBarley to see how this sort of AI-based technology can work. And Peter, can you tell us about the first time you're introduced to this and how that came to pass?
Yeah, we were contacted by the CMBTC was contacted by Zoom Agri actually originally in the spring of 2022, I believe it was, and in the fall of and so we had been in touch. We didn't have any familiarity with the technology at that time. In the fall of 2022, the Canadian malting barley industry started to notice some fairly high levels of impurities in malting barley samples that were being delivered into the system. And typically end users, as Augustine spoke about earlier, prefer above 95% varietal purity. So we were perplexed and we thought, okay, we need to get to the bottom of this challenge. And of course, we were relying on the DNA tests at the time, and they are quite expensive and time consuming. So it was timely that we were in touch again with Zoom Agri. They introduced the technology to us then in the fall of 2022. And we quickly moved to establish a partnership with them and started working on the project quite quickly to bring the technology to Canada. Like Todd Hyra said earlier, I was very skeptical when I first heard about the digital imaging to be able to do varietal purity identification, but we were convinced quite quickly that this was possible. But also, Olha had joined our team in the fall of 2022, and she had previously worked with Mall Europe in Ukraine, and they had tested the technology, and she was able to confirm that indeed this technology worked. So that provided us with a lot of confidence, since Olha had been working with the technology previously.
Yeah, in terms of working with the technology, I mean, how would you each describe, the capabilities of this sort of AI-based technology? I mean, what makes this unique compared to traditional seed identification methods? I mean, I want to emphasize that genetic testing is integral to seed identification. It's that gold standard. But this is, it seems to me like a supplementary kind of technology where we're using AI to identify varieties quickly when needed. So, what is it essentially allowing you to do when it comes to malting barley?
Maybe I'll let Olha speak to the efficacy of the system, but I do agree, Mark, that and has been mentioned a few times that the DNA tests are complementary. The Zoom-Agri is an inexpensive, quick, rapid test, but those can be backed up and confirmed with DNA tests. So let's say, for example, Olha receives a sample and screens it, and identifies a high level of impurity. If the seed company or the malting company or grain company comes back and says, "Ooh, that's surprising," it can always be confirmed by DNA. But it's a quick and rapid test that can really potentially save a lot of money for the industry by identifying screening out potential problems ahead of time. Maybe Olha, do you have any comments on the efficiency of the system, the efficacy of the Zoom-Agri system?
I would just only add that the speed of analysis, like 2 minutes, would let. I will say about malting industry because I worked there. When you need fast decision, especially when, like Augustine said before, a lot of trucks are waiting for decision, or you have some batch storage, barley storage under consideration, what to do with that further. And we didn't use it in Ukraine, I explain later, but I would use it, of course, for malting to make any decision more like efficient and fast.
Yeah, like this is
That's
really
it.
different. Like you were saying, how you were originally introduced to this thing, sort of technology in Ukraine, and how does it compare today from your initial experience in Ukraine? I mean, all technologies evolve. I mean, AI is moving really fast. I mean, when I think about ChatGPT, just having started using it when it first came out compared to today, like it's really progressing quickly. I imagine you're seeing that same sort of progression when it comes to using AI for variety identification purposes.
Yes, there is a difference, especially in accuracy. In Ukraine, that time at Malturob, we were working only pilot project with Zoom-Agri because it was the very beginning, and we tested samples from various regions. And that time the accuracy was below 95%. Anyway, it was even for that time enough high value. And that's why we actually started that pilot project. And the only thing we didn't implement it in Ukraine, but the reason was that we had a well-organized program for variety multiplication and development across several regions. And thanks to that we had no serious issues with variety purity. But thanks to that trials, that methodology have been implemented in other business units in Europe later. And as we used the European barley varieties, that allowed us to provide samples of pure seeds to Zoom-Agri that they could build like base for their algorithm for European varieties at least. Yes, and now we see that accuracy is much higher. It's up to 98% even. And of course, having such huge amount, as Augustine shown us before, such huge amount of samples, feeding algorithm, it will be with the time, I suppose, more accurate even.
Yeah, well, I'm going to bring Augustine back to the stage actually, because I'm curious. So when you take an image of a barley seed or a barley grain, and like, is this? I'm assuming like this is like a microscopic image, and then you're taking this, you're feeding it into the AI, and the AI is actually telling you like what variety it is. Like how is this working? I mean, once these images are digitized, they're stored. Like, what happens next in terms of algorithm development? Like, how does the AI learn to distinguish between two varieties of barley? I mean, that just seems amazing. So I'm assuming it must be looking at this barley on a microscopic level and can actually recognize like what's what.
No, it's a very good question. I mean, we work with images RGB, red, green, blue,
Ah,
that are like visual parameters. So what we do is to collect pure samples from different locations, because with morphological variability can come from multiple locations. So we want to make sure that the algorithm will learn which pattern makes unique each variety. Because like years ago, I understand that there were some people that could, not with a 98% of precision, but were able to differentiate varieties. So our hypothesis was, hey, if a human eye can make it uh, quite well, we are going to be able to probably do it better with very high resolution images and using the power of AI, right? So what we do is we use RGB images, we digitize each sample, then we use, and at the end is like images are like maths calculations, like dots. I think it's DPI, dots per inch, and maths calculations, and all that mathematical calculations are seen by the algorithm, and with that images, the algorithm learn what makes unique each variety, right? So I show a lot of pictures of Mark, a lot of pictures of Peter, a lot of pictures of Olga, a lot of pictures of Augustine, and at the end I start showing pictures that the algorithm never saw, and the algorithm will start, hey, this is Mark, this is Peter, this is Olga, this is Augustine. Of course, sometimes between Mark and me is going to be more difficult because we don't have a hair both. So uh, but it's pretty the same. Like if varieties are similar, genetically similar, like we could be Mark and me, it's going to be more challenging. So we need more pictures, and but at the end, it will start differentiating us. Okay.
wow. So it's looking at these, it's actually RGB, it's using like colors to distinguish. Like when I use Photoshop, you have RGB images, you have CMYK, you have different color schemes. And so this is almost using the same sort of technology to tell the difference between barley
Yeah,
varieties.
yeah.
Wow.
Looking the size,
Yep.
the yes size, like every morphological feature that can make a variety unique, the algorithm's looking at it.
Wow. Wow, that really is incredible. So yeah, I'm curious, and we can start our Q&A now. Again, if you have a question, please type it into the chat box. And we actually already have a question. Can the Zoom Agri technology analyze the sample and quantify the amount of each variety, or can it only say the sample is a majority of
Good
one
question,
variety?
Martin. Um, we analyze individual kernels, right? So you place the sample on the scanner. The scanner will take the picture, and then it analyzes each individual image, and at the end it provides you a result of percentage per variety. So if you have 100 kernels, 75 of them is Copland and 25 is Synergy, it will give you a result of 75, 20, so 25.
Wow, Peter, I'm curious, how do you envision the Canadian malting and grain industry being positioned to adopt these sorts of technologies? Are there any regulatory or operational hurdles right now? What does that environment look like for being able to use this sort of AI technology on a wider scale?
I don't see, there's no regulatory hurdles that I'm aware of, Mark, but operationally, obviously, as Olha mentioned, for a malting or a grain company, this technology can be very advantageous in terms of screening samples, as Olha mentioned, in terms of your storage and you're batching up the same varieties, because for those that aren't aware, the malting industry, and Augustine mentioned this earlier, they process malting barley variety specific, and that's very important because malting barley varieties, depending on their chemical physical properties, will process at different rates and have different quality characteristics. So the varietal purity is extremely important. So when a grain company or malting company is receiving those samples, to be able to quickly and efficiently assess them, maybe on the driveway, can be really advantageous. But you do have to have a machine. There's a unit that a large scanning unit that has to be on site, and so that's not always feasible for every, say, grain elevator to have. But for perhaps for the companies that have in big malting barley growing areas where they're taking in a lot of barley, then it would make sense operationally. So obviously, like any business, it has to make sense. But we've seen lots of instances already, Mark, where companies that are testing the technology or using the technology are identifying problems on delivery that are saving them headaches and money down the road. So it's pretty cool.
Yeah, it is. Sorry, go ahead, Augustine.
No, Mark. Yeah, I wanted to add something to what Peter was mentioning. Is that what happens usually in terms of go-to-market and adoption in each country? Usually, companies start doing the first year they use it as trying to be able to know what's the situation with what they are receiving, right? So they don't have a lot of devices at their elevators. They analyze it like the central lab or whatever. They analyze a lot of samples to make sure what's the status of what they are receiving. What happens sometimes, usually, is that they find out, as Peter said, sometimes some problems that they found late, and they are willing to start finding them at their reception point, so they prevent from them, right? And so that's when they start analyzing at the first point of reception at the elevators. In Canada today, we're mostly analyzing at central labs. But for example, in Argentina, today, we have like 110, 120 units installed at elevators. We have one customer that they have one device at every reception point, and they are analyzing 100% of the trucks that they receive with malting barley, preventing them to get trucks contaminated into the silo and contaminating the whole silo. For your reference, in Australia, we had one customer that they have 40 units installed. In the last 4 years in Argentina, we analyzed the equivalent to 100% of the malting barley total Argentinian production. So, and my expectations is to have that kind of amount of analysis, or hopefully in all the countries, right?
Wow. Yeah. No, it's pretty amazing. And as I said to Mitchell earlier, there's so much more to AI than ChatGPT, and so it's just amazing to be able to show specific cases of AI in action that really has such potential. I mean, when I think what we could do down the road, at the elevators and things like that with grain delivery, and it is pretty amazing. So
100%. And it's good what you're saying about the use cases, right? Because we
Yeah.
found out not only for barley, but also for soybeans or wheat, different use cases in different countries. So that's amazing, because the same technology, different customers, different countries are looking for different use cases. For example, in Argentina, through wheat variety recognition, we are able to determine if a truck has or not has GMO wheat. So all the traders, grain companies, milling companies cooperatives, their commercial contract says non-GMO wheat, so they have to make sure that they are not receiving GMO wheat, and they are using our technology through variety recognition to make sure that they are not receiving GMO wheat. But for example, in Brazil, companies are buying wheat per class, like in Canada, right? And different classes have different prices or different quality or different uses, and they were not being able to make sure that they are receiving the class that they are paying for. And through variety recognition, with variety recognition, now millers in Brazil, they are able to make sure that they are receiving the class that they are buying. So that's very interesting.
It is. Before we log off, Olha, I'm going to give you the last word. Now's your chance to tell Augustine. I'm going to get you to gaze into your crystal ball, and if there's one thing you would like to see this technology do for someone like you, a researcher, is, boy, if we could have this ability to do that. Now's your time to tell Augustine, please do this. Is there one thing, Olha, that in 5 years, 10 years, like, boy, if we'd be able to use this technology to do this, what would that one thing be?
I already told him. He knows. I asked. I remember that at my previous job, the biggest headache was pre-germinated grains, and of course, if main dream of every laboratory technician would be to have using this AI for grading. But for maltsters, it would be avoiding of that situation with pre-germinated grains, especially in the very wet years. And we discussed it already. They know, and they studied it.
Well, I'm sure he's working very, very hard on it. So, thank you so much. Thank you, Peter and Augustine and Olha, for joining me today. And I want to thank Todd and Mitchell as well for their time. This has been fantastic webinar. Learned lots of great stuff. This article webinar will be on our website, seedworld.com/Canada very soon. So feel free to check that out once it's online. I want to thank our sponsor, CCAN, one more time for their support. And again, a recording will be available very, very soon. So check it out, seedworld.com/Canada. I want to thank all of you for your time. Thank you to our audience for spending your lunch hour with us. I had a great time today. Thank you, Peter, Olha, Augustine. Have a great day.
Thank you.
Thanks, Mark.
Take care, everybody.
Bye now.